Okay, welcome to the video for the day 4. Today we're going to talk about exponential application word problems. So to answer these, remember that you'll need to know the equation for exponential functions. In order to find them for application word problems, we'll need to use the exponential equation and then fill in the information that we know. So to do this, we'll need to determine the A number, which is your initial or the principal amount. This is how much you're starting off with. Then determine the B number as a growth if it's over 100% or a decay if it's under 100%. If it's a growth, meaning it's over 100%, we'll convert the percent to a decimal to be used in the problem. If a decay under 100%, determine how much it is under 100, and then this will be the new percent that will be converted into a decimal to then be used in the problem. Let's try looking at one together. We have an oil spill is spreading such that its area is given by the exponential function A of t equals 258 times 1 and 1500ths, that's at 1.15, raised to the t power, where A is the area in square feet. So I just highlighted that to know that what A is standing for. That's my output, and then T, input, is the time in days. So in this first question, it's asking how large was the oil spill initially? That's the key word here. Initially, that means starting off. So at the beginning, before any time has passed, what is the size of the oil spill? Well, we have two options for this. We could put this into y equals and say y equals 250 times the 1.15 to the t power, which we would need to put an x in if we were putting it in y equals in our calculator. Then we would go to second graph to look at the table and find out what the output is when the input is 0. We could also put in the 0, but as soon as I saw it initially, I just know that in my equation for a general exponential function, y equals ab to the x power, the a stands for the initial value. So if I look here, the 250 is in place of the a, so that means that 250 is the initial area, so 250, and they said feet squared, area in square feet, so I'm going to just label that with feet being squared since they told me that label in the question. So again, that came from the A number in the equation. By what percent is the oil spill increasing each day? Well, if we think about this 1 and 1500ths, what does that mean as a percent? Well, that means if I move this 2 places to the right, I'll have it as a percent. So 1 and 1500ths is 115%. So now knowing that, if it's 115%, I think that's a little easier to say, oh, okay, well, how much over 100 is that? That's a 15% increase. That's 15% over 100%. If it's 100%, it's going to stay exactly the same. So any amount over that is how much it's increasing. Okay, let's look at the next one. In 1995, there were 85 rabbits in Central Park. The population increased by 12% each year. How many rabbits were in Central Park in 2005? Okay, so this time we have a lot of information. We're still going to use this general form of an exponential function that I wrote up above. So remember, that's what we're always going to use whenever we're talking about exponentials. I'm going to fill in what I know. So we could use y equals since they didn't tell us to use function notation or anything like that. So I'm starting off with y equals. And then initially, how many are there initially? What's the starting off value? Well, it's 85. And then is it growing or decreasing? It's growing. It's increasing 12%. So if we think of increasing 12%, that means that I'm going up 12% more than the 100 that I started off with. So off to the side, we can write this as a percent. So because this increased by 12%, I started off with the 100%. That would mean what I'm starting off with. I added 12% for the increase of 12% to give me 112%. Now I can change this to a decimal by taking the decimal point now, which would be after the 2, and moving it left 2 places to get 1 and 1200ths, 1.12. Then it's ready to go into my b value in my equation. So 1 and 1200ths. We could write it to the x power as just a formula, a general formula that can be used, but this one didn't ask for a general equation, so you don't have to. Sometimes, though, they'll ask you to write it as an equation first and then use it, so it's not a bad thing to just write it one time beforehand to make sure that you don't miss that if they do ask you to write an equation first. This time we're asking for 2005, so I have to think about that. In 2005, this started in 1995. So how many years have passed from 2005? If this started in 1995, that would be 10. So that tells me that in my exponential equation, I'm going to plug in a 10 for the x, the amount of time. Okay, now this is a job for my calculator, so I can go ahead and put in the regular screen because I don't have any variables or anything, so I don't have to go to y equals. I can just put in the 85, and then you could have parentheses around the 85 if you want to. You don't have to, but you need, and then you would sub in to show the multiplication. So parentheses 1 and 1200ths raised to the 10th power. And then hit enter in your calculator. You get a long decimal, so we get 263.9970977. So the rule generally when we speak about living and breathing things is that we can't create a living and breathing thing. If they took a census and they walked around and they said, how many people are in your family? You can't, even if someone is pregnant and about to have the baby, they don't count into being there just yet. So we're actually going to just round this down to say that at this point there are only 263 rabbits. Even though it's super close to 264, unless they give me rounding rules, I just always round down because that last one is not actually there yet. So that would mean my answer would be 263 rabbits. Okay, the next one we have here is water that's draining out of a pool. The depth of the water is decreasing at a constant rate of 20% per hour. The depth of the water when the draining begins is 12 feet. Write an equation that gives the depth d of water in the pool as a function of the time in hours t. So before, this is one of those questions where they're making us write it before we can even start plugging anything in. So they told me to use d and write it as a function of time, so d of t equals. Then I know this is exponential because it's a constant rate of 20% per hour, so we're multiplying. That means that I need to put in my y equals ab to the x power equation that we wrote up above, exponential function. So the initial value, how much is it starting off at? Well, it's starting off at 12 feet. B value, decreasing. It's decreasing 20% per hour. So that means that each hour we're starting off with the 100% of the water and then we're decreasing 20% each hour. So that means that my pool is actually going to be 80% full. So in place of the B value over here, I'm not putting anything with the 20%. I use that to find out how much of the pool is actually left. It's losing 20%, but that means that it's actually 80%, which changed to a decimal is 0.8 or 8/10 or 0.80, 80/100ths. Either way is fine. And then raised to, and we have to use t because they told us to use t in the question. So that's my equation. That can then be used to answer follow-up questions, but this is just the formula that I'm going to use. The next question says, what is the depth in 5 hours? Just to make sure hours is what my t was talking about. So that's good. I'm going to put in the 5 in place of my t value. This information here tells me that the t value is equal to 5. So now going to my formula, I'm going to replace my t's with 5's. So now I've just rewritten it with the t in place, or the 5 in place of my t. Then it's a job for our calculator, so we'll plug in the 12, and then remember to put the parentheses to show that it's multiplication for the 0.80 or 80/100ths. raised to, so remember that's under the clear button, the fifth, and then you hit enter and we get 3, and then 0.93216. So they didn't give me any rounding rules or anything, so I'm just going to leave it as that. So that means that the exact depth would be 3, and then we have this 0.93216 feet. That would be my depth after T hours exactly. Because they didn't tell me what to round or anything, so that's why I chose not to round it to 4 or anything like that. I just wanted to leave it exactly the answer I was given because I wasn't told to round or change my answer in any way. Okay, the next one says, it's safe to cover the pool after it reaches a depth of 1 foot or less. What is the minimum number of whole hours? So now this is a question where they're directing me to look exactly at the whole hours, no decimals, that we should wait to cover the pool and explain how you found your answer. So for this one, I know what I want my output to be. I don't know what the exponent is. That's very difficult to do with our knowledge base at this time. So what I'm going to do is I'm going to go to y equals in my calculator. So remember that's on the left side up at the top below the window screen. In the y equals, we're going to put 12 parentheses 0.8 or 0.80, close your parentheses, caret, remember that's under the clear button, and then the X, which remember is next to the alpha button. Then you can hit second, which is the blue button or some colored on your calculator above the alpha button. Second, graph, which is all the way to the right below the window for your graphing buttons. Then you should get to a table of values. Now, depending on where you start, you might start at 0, or yours might be somewhere else. Remember, you can change that by hitting second window to table set to change what your table is starting at or to change what you're counting by. So if I go to start at 0, that's 12 feet. I need to get to 1 foot or less. So as I'm scrolling down, I see 9.6, 7.68, all the way down. At 10, it's 1.2, but that's not below 1. 9 was 1.6, that's not below 1, so those don't work. But then I see 11 getting really close, 1.03, but that's still not below the 1 foot that I need. 12 is 0.82, there I finally reached below the 1 foot mark. So I'm going to start by writing down my table of values. Okay, so we can see here, I just wrote down my table. Now yours might be slightly different for the outputs depending on which calculator you're using and how far out they rounded. They might have all rounded at the same number, but they should be close to the numbers that I have written here. So now it's asking me what is the minimum number of whole hours. So if we're looking for whole numbers, I can't use 11 because at 11 it's still not time to close the pool. So if I'm going for whole hours, I have to wait all the way until 12 hours when it's finally below that 1 foot mark. Then I could cover my pool. So my answer is 12 hours, but then they asked me to explain how I found that answer. So it's 12 hours. I found my answer by substituting the equation into y equals in my calculator and checking the table of values for an output that is below 1. So something along those lines, just explaining exactly what you've done. This is so that people who aren't there with you know exactly what you did to find the answer that you wrote. Okay, so that's it for today. We'll continue this by completing the next page in class tomorrow. So have a wonderful day. See you tomorrow.